Okay, now let's take a look at solving some problems with correlations. So here we're going to use practice problem number 9 on page 498, and I've got the data there for you at the bottom. And we're going to go through several steps for examining the data and working with it with a correlation. So first we're going to construct a scatter plot, then we're going to find the value of the linear correlation, and then we're going to go through and determine whether or not that's sufficient evidence to support the claim for the linear correlation. So let's take a look at our different steps in doing this. So first of all, in constructing a scatter plot, which we should always do before we go any further with our data, you're going to want to go to StatsCrunch. When you open up StatsCrunch software, you're going to go through and enter your data, just as we've been doing all semester long. Once you have your data entered for your columns, you're going to want to select the option to graph it. Then you want to pick scatter plot, and then you're going to need to select your variables. So you're going to want to select one column for your x variable and one column for your y variable. So pause the video here, open up your StatsCrunch, get your variables entered into your software, go through these steps, and then when you've completed that, turn the video back on and we'll move on to the next step together. Okay, be careful here, by the way, that you are careful with entering your data. Incorrectly entered data is a leading cause of incorrect answers. So before you move on to your analyses, double check and make sure you've got all of your data entered correctly. All right, so here's what you should get is a plot that looks something like this for our scatter plot. So does this scatter plot indicate that the sample meets all of the requirements for a correlation analysis? Why or why not? Looking at this sample, does this meet the requirements or does it not? Well, in fact, it's not meeting all of our requirements because it's not strictly a linear relationship. That actually looks like we've got the beginning of a curvilinear relationship where the variables are going up to a certain peak and then starting to drop back down. So the one here front part is a positive relationship, and then peaking up at the top, it looks like it starts to turn into a negative relationship. So now that we've taken a look at that, we're going to find our value here. So for doing this, you're going to go back with your data that you already have entered. You're going to open up the option for stat. You're going to open the option for regression, and then simple linear. Once you have that open, you're going to go through and select your variables, leave it at the automatic setting, so you don't need to change anything for the hypothesis testing. For this, we're just going to keep it where it's set automatically. And you should get an output that looks like this. This is an awful lot of data. They throw a lot of data at you here, and indeed, as you go on in your work in doing your analyses, you're going to find that one of the problems is that output actually gives you way more than you often need, and part of what you have to do is figure out what pieces you do need to pull out. So for here, we're simply going to be working with a single piece of all of this giant amount of data, and that is going to be the R correlation coefficient given there. So that number is going to be our R obtained from our sample. So in this example, it is going to be 0.816. So that is our R obtained. So if we come back down to our problems, we're going to enter that in as our value for option B. And now we need to determine if there's sufficient evidence to support the claim of linear correlation between the variables. So making this assessment, we need to pay attention to general norms for strength of a correlation. A correlation of 0 to 0.2 is often considered not really any correlation at all. So 0 means there's no relationship between the two variables in any way, shape, or form. A 1 means it's a perfect relationship between the two variables. Absolutely perfect. No variation along the line. Obviously, you almost never see a 1. That's pretty much doesn't exist working with live data. So you can get this value and comparing it over to the R that we've got, we can see that our R value of 0.816 is actually a strong correlation variable. So we would be able to say, yes, we feel very confident about this is a strong linear relationship. So we're almost through practice problem number 9. Our very last step here is identifying item number D. So identify what feature of the data you would have missed if you had skipped part A. And in fact, what you would have missed is that actually this is a curvilinear relationship. So here you can see where I've plotted the fitted line for the scatter plot. And you can see that the relationship between the two variables, although it's still a really positive, strong correlation of 0.816, it's actually slightly misrepresenting the actual plotting of the data. And we probably could do a better plotting of the data if we were using a different correlation approach or otherwise grouping the data differently. So this is why you always plot your data first before you begin to do your analyses, or you could have made the mistake of saying, oh, I've got an R of 0.816, that's a strong relationship, we're good, and you're done. When in fact, there are some better ways of explaining and working with your data.